Welcome to lesson 4-7. That's topic 4, lesson 7. Today we're going to solve some inequalities. You're going to find it's much like solving equations or equalities. Let's get into it. Let's start off by graphing what some of these solutions look like. So we have this inequality, x is greater than 5, and it's asking us what are some possible solutions. Well, greater than 5, let's see. How about 6 or 12 or 128 or, oh, I could keep going and going and going, right? Lots of possible solutions. Now this next part says use the graph to show all the solutions of x greater than 5. What? There's an infinite number. How could I show them all? I mean, sure, we have 6 is greater than it, 7 is greater, 8 is greater, 9 is greater, 10 is greater, but I haven't shown them all yet. I haven't even gotten 128 yet. And what about the numbers in between? How am I going to show them all? Well, don't you worry, young mathematicians. We have a way. Mathematicians have figured this out. We want to know everything greater than 5. Well, we can't include 5. Let me put a circle of protection around that. There's my big circle of protection. It does not, there's a hole there. There's a hole, and we're not including 5. And if I kept putting dots for every point in between, eventually what I'm going to get is a solid line here. And then I'm going to put a dark arrow there to show that it includes everything even beyond that. And there you go. That's the solution for x is greater than 5. Doesn't include 5, that's why we've got a circle around it, but everything above the circle is included. And what about a solution of x is less than 8? Well, 8 is not less than 8. I want to put a circle around that. It's not going to include 8, but it's going to include everything below 8. So I'm going to draw a solid line with a dark arrow to show that everything on that side of 8 is part of the solution. Everything on that side of 8 is less than 8, but not 8. So I've got an open circle around 8. All right, let's look at some more inequalities. The barbecue beef dinner entree is the most expensive menu item at the Flamingo restaurant. It's the most expensive thing in the store. We want to know all the other possible costs on the menu. We're going to write and graph an inequality for that. Let's go ahead and graph all the possible costs of items on the menu. Well, the thing could cost $12.25. So I'm going to put a circle there, and I'm going to color it in. I'm not going to put an open circle because it does include $12.25. It could be that price. And it also could be anything that is less expensive. So I could do a solid heavy line going this direction with an arrow here. Notice though the important thing, that is filled in. It's not an open circle like before when it was not equal to. It could be equal to $12.25. Well, I bet you're thinking to yourself, Mr. Edwards, what about that other way we wrote it? The inequality way with symbols. Doesn't that seem like it might be a little more efficient? And it is. Let's see how that might look. If I had the price of a menu item as compared to $12.25, the price could be less than or it could be equal to. So you would read this P is less than or equal to $12.25. And that's the really cool way to do it.
That's great!
And not to beat a dead horse, but remember, if I had less than, I have an open circle because it doesn't include the value. If I have less than or equal to, I'm going to fill that in because it does include it. It's like filling in the multiple choice answer. This one, this one. So there you go. All right, here's one for you to try. There's no menu on the children's menu, no menu item on the children's menu at the museum restaurant that costs more than $8.50. Nothing is more than $8.50. So I want to know what the possible costs are on the children's menu. So we're going to graph it, graph the solution the way I showed you above, and we're going to write an inequality. And you're going to write one of those too. Be careful about whether it's open or closed circle. and we'll talk about it next time in class. All right, so now we're going to try and evaluate some of these inequalities. So we have a long jumper who jumps at least 18 feet, and that's necessary to qualify for finals. And so I could put a jumper, a J, has to be at least 18 feet. So it could be more than 18 feet, or it could be equal to 18 feet. So there's a nice inequality for that. Oh, they asked me to use Y, but I use J because I think J is better. And now we need to see who qualifies looking at their times. Well, we could one at a time plug it in for J. But look at here, Amir was 22 and 1/3 feet. That certainly is greater than 18. 16, not so much, not greater than. 18 and a half, that's greater than 18. And 20 and a half is also greater than 18. So Amir, Tyrell, and Ryan all qualify. Hooray for them. All right, now we're going to have one for you to try. Now we want to know who qualifies for the finals if they need to go at least 20 and a half feet. Go ahead and write yourself an inequality and then determine who qualifies. Good luck to all the competitors. Here's some straight up practice. We have some graphs here and you need to write the inequality. Now, pay close attention. Is the circle at 14 colored in or not? What does that mean if it is or is not? Same thing with the second example. The circle at 18, is that colored in or not? And what does that mean? So write me some inequalities and we'll go over it next time. See you later.